Hello students, good evening. Today we are solving few questions on aldehydes, ketones and carboxylic acids. See the first question, the compound that produce CO2 with aqueous NaHCO3 solution. Which compounds produce CO2 with aqueous NaHCO3 solution? NaHCO3 is sodium hydrogen carbonate, or this is also considered as sodium bicarbonate. Sodium bicarbonate. Which compounds gives positive sodium bicarbonate test? Which compounds gives positive sodium bicarbonate test? This is the hint. The acids which are stronger than carbonic acids, then the compounds produce CO2 gas. So, according to the given options, which gives positive sodium bicarbonate test? Generally, carboxylic acids are gives positive sodium bicarbonate test. Sulfonic acids is also gives positive sodium bicarbonate test. Even 2,4,6 trinitrophenol is also gives positive sodium bicarbonate test. Why 2,4,6 trinitrophenol gives positive sodium bicarbonate test? Because here 3 NO2 groups are present. NO2 groups are electron withdrawing groups. Acidic nature is directly proportional to number of electron withdrawing groups. So now you can check it. A, benzene with CO2H. CO2H means nothing but COOH. Carboxylic acid functional group is present. Gives positive sodium bicarbonate test. This is phenol. Does not gives positive sodium bicarbonate test. 2,4,6 trinitrophenol gives positive sodium bicarbonate test. Carboxylic acid gives positive sodium bicarbonate test. This is alcohol, does not gives positive sodium bicarbonate test. So the correct answer is third option. The next question, carboxylic acids reacts with LiAlH4. What is the role of LiAlH4? LiAlH4 is present, a reduction process takes place. Carboxylic acids undergoes reduction, then it gives alcohol RCH2OH. Now alcohol reacts with PCC. What is the role of PCC? PCC is present, oxidation process takes place. This is 1 degree alcohol. Here PCC is present, oxidation process takes place, cleavage the bond between oxygen and hydrogen, carbon and hydrogen. Then it gives aldehyde, RCHO. Aldehydes are participate in nucleophilic substitution reactions, nucleophilic addition reactions. HCN dissociate like H plus CN minus. Break the bond between carbon and oxygen. Oxygen gets negative charge, carbon gets positive charge. So Cn minus is moves towards carbon side. Then it is converted to RCH CnOH. Now cyanides undergoes hydrolysis. Cyanides are undergoes hydrolysis. Then it gives carboxylic acids. So the correct option is fourth option. Cyanides undergoes hydrolysis, then it gives carboxylic acid. How is it? Take the cyanide, RC triple bond N, hydrolysis, H plus, OH minus, Break the bond between carbon and nitrogen. Nitrogen gets negative charge, carbon gets positive charge. Then it is converted to RCOH double bond NH. Which on further hydrolysis, H plus OH minus, break the bond between carbon and nitrogen. Nitrogen gets negative charge, carbon gets positive charge, and it is converted to RCOH, OH, NH2. Two OH groups on same carbon atom. This is gem diol. Gem diols are unstable, which on further heating, it loses water molecule and it is converted to amides, RCONH2. Amides undergoes further hydrolysis, H plus OH minus, then it is converted to carboxylic acid. Simply remember cyanides undergoes hydrolysis, complete hydrolysis, then it gives carboxylic acids. So fourth option is correct option. See the next question. Carboxylic acid reacts with bromine, red phosphorus. Carboxylic acid, bromine, red phosphorus. Carboxylic acid with alpha hydrogen atom. Here, alpha hydrogen atom is present. Carboxylic acid attached carbon atom is considered as alpha carbon. Alpha carbon contains alpha hydrogens. Alpha hydrogen atom is present, reacts with bromine in the presence of red phosphorus. This is considered as HVZ reaction. Remove alpha hydrogen atom. In the place of alpha hydrogen atom, substitute bromine atom. So, the correct option is fourth option. Next question is matching type of question. Reagents are given. What is the name of the reaction? H2PdBsO4. This is Rosenman reduction reagent. SnCl2 plus HCl. This is Stephenson reaction reagent. A is 2, B is 4. One option, that is second option. See the next question. Which one of the following reaction will not yield propanoic acid? This is alkyl halide. Alkyl halides are reacts with magnesium. Then it gives Grignard reagent. CCCMGBr. Grignard reagent. CH3CH2CH2MGBr. Now Grignard reagent reacts with carbon dioxide. Break the bond between alkyl group and magnesium. Magnesium gets positive charge, alkyl group gets negative charge. Break the bond between carbon and oxygen. Oxygen gets negative charge, carbon gets positive charge. Negatively charged alkyl group is attached here. Then it gives CH3, CH2, CH2, C, double bond O, MGBr. Which on further hydrolysis? H2O is dissociate like H plus OH minus. Remove MgOHBr. Then it gives CH3CH2, CH2, COOH. Name of this acid is butanoic acid. Butanoic acid. Which one of the following reaction will not yield propanoic acid? Fourth one will not yield propanoic acid. Here observe one point. Suppose Grignard reagent reacts with carbon dioxide, which on further hydrolysis, then it gives carboxylic acid as a product. The next question, esterification of carboxylic acid with alcohol. is a nucleophilic acyl substitution. Yes, in already last video we discussed about this. Statement 1 is correct. Electron withdrawing group in carboxylic acid will increase the rate of esterification reaction. Yes, statement 2 is also correct. Both 1 and 2 are correct statements. Here, note down the point. The rate of esterification is directly proportional to electron withdrawing group. That means inversely proportional to electron donating group. Next question. Alkyl benzene reacts with the alkaline KMnO4. This is also according to NCERT nothing but KMnO4 KOH, which on further hydrolysis. KMnO4 KOH is present, side chain oxidation process takes place. Side chain oxidation takes place irrespective of carbon chain length. In this process, alkyl group is converted to carboxylic acid group irrespective of carbon chain length. It gives benzoic acid. The correct option is second option. See the next question. Increasing order of acidity, acidic nature, increasing order. What we know, acidic nature directly proportional to electron withdrawing group, inversely proportional to electron donating groups. So first of all, here NO2 group is electron withdrawing group. OH is electron donating group. CH3 is also electron donating group. So NO2 is electron withdrawing group. Electron withdrawing group increases the acidic nature. So one is more acidic. Okay, remove the second option. Now you can consider CH3OH Cl. Cl with respect to inductive effect, it is electron withdrawing group. With respect to resonance effect, it is electron donating group. So 3 after 2. 3 after 2, only one option is there, first option. Remember, remaining here 2 electron donating groups are present. Compared with CH3, according to resonance effect, OH group is strong electron donating group compared with see the next question. The major product of the following reaction. Reaction is given, reacts with the CrO3. Alcohol reacts with CrO3. What is the role of CrO3? Oxidation process takes place. Partial oxidation process takes place. Partial oxidation or oxidation process takes place. Oxidation takes place. Alcohols are undergoes oxidation. Alcohols are undergoes oxidation. 1, 2, 3 carbon. 3 carbon alcohol undergoes oxidation. Then it gives carboxylic acid, COOH. Now carboxylic acid reacts with SOCl2. What is the role of SOCl2? It cleaves the bond between Break the bond between carbon and OH. In the place of OH, substitute Cl. Then bond OH, C double bond O, Cl. C double bond O, Cl, which on further heating, it loses HCl molecule and it gives compound like this. OH, C double bond O, new bond is formed between carbon and carbon. So second option is correct option. See the next question. Carboxylic acids reacts with SOCl2. Reacts with SOCl2. Role of SOCl2 is it breaks the bond between carbon and OH group. In the place of OH group, substitute Cl. Then it gives CH3COCl. It is in the form of RCOCl. RCOCl reacts with benzene. Friedel-Crafts acetylation. Then it is converted to C6H5COCH3. This is ketone. Ketone is a carbonyl compound. Carbonyl compounds are reacts with HCN. Nucleophilic addition reaction takes place. Add the nucleophile, pi bond is delocalized, then it gives COH, CN, CH3. Now, which undergoes further hydrolysis? I already discussed with you. Cyanides undergoes hydrolysis, then it gives carboxylic acid. So C, COOH, CH3, OH and benzene ring. So first option is correct option. See the next question. The next question is a liquid was mixed with ethanol. Liquid, unknown liquid mixed with ethanol. Ethanol is a alcohol and a drop of concentrated H2SO4. Reaction takes place in acidic medium. A compound with a fruity smell. Fruity smell compounds are called as esters. That means ester is formed as a product. Then the liquid was. We know that ester formation reaction. How ester is formed? Carboxylic acids or acid chlorides or acid anhydrides reacts with alcohols, then it gives ester. Here carboxylic acid, this is carboxylic acid, so fourth option is correct option. See the next question. Which of the following undergo reaction with 50% sodium hydroxide, 50% NaOH, then it gives corresponding alcohol and salt of carboxylic acid. According to given data, it is a Cannizzaro reaction. Which compounds are participate in Cannizzaro reaction? Aldehydes without alpha hydrogens. Aldehyde without alpha hydrogen. Phenol wrong option. Benzoic acid wrong option. Butanol contains alpha hydrogen, but benzaldehyde C6H5CHO alpha hydrogen atoms are absent. So it participates in Cannizzaro reaction. When CH2 double bond CH is reduced with LiAlH4 lithium aluminum hydride, it reduces carboxylic acid groups. Important point is C double bond C group unaffected. So C double bond C group as it is. Carboxylic acid undergoes reduction, then it gives alcohol. So the correct option is first option. Which compound has highest boiling point? Which compound has highest boiling point? Generally what we know, boiling point is directly proportional to hydrogen bond. Aldehyde does not form hydrogen bonds. Ethers does not form hydrogen bond. Alcohols are able to form hydrogen bond. Even carboxylic acid is also able to form hydrogen bond. Here, due to hydrogen bond, carboxylic acid is available in the form of dimer. That means the molecular weight of carboxylic acid is abnormally increases, but alcohol is not available in the form of dimer. So the correct option is third option. See the next question. Carboxylic acid reacts with chlorine red phosphorus. Given carboxylic acid is alpha hydrogen atom containing carboxylic acid. So it participates in HVZ reaction. Remove one alpha hydrogen atom. In the place of alpha hydrogen atom, substitute chlorine. Substitute chlorine. Then CH3, C, Cl, H, COOH. What is the role of alcoholic KOH? It acts as dehydrohalogenating agent. Dehydrohalogenating agent, beta elimination takes place. Remove hydrogen atom from beta carbon, halogen from alpha carbon. Then CH2 double bond, CH, COOH. Final product is third option is correct option. See the next question. Give reactivity order of decarboxylation. Decarboxylation. In case of decarboxylation, the reaction intermediate is carbanion. When carbanion is stable, the stability of carbanion is directly proportional to electron withdrawing group, inversely proportional to electron donating group. But here alkyl groups are present. Now you can check the reaction intermediate. Break the bond between carbon and COOH group. Then decarboxylation. First compound reaction intermediate is CH3CH2 minus. Second compound reaction intermediate is CH2 double bond CH minus. Third compound reaction intermediate is CH triple bond C minus. So order of stability of carbanion. Order of stability of carbanion is 3 is more stable. After that 2, finally 1. Reactivity of carbanion is also same. 3 greater than, 2 greater than 1. Why this carbanion is more stable? Because it is sp hybridized. S character is more. S character is 50%. Here S character is 33.33%. Here S character is 25%. S character is directly proportional to stability of carbanion. See the next question. CH3 taken thrice, CCOOH does not give HVZ reaction. Correct. Why? Because alpha carbon is present but alpha hydrogen atoms are absent. Reason: CH3 taken thrice CCOOH does not have alpha hydrogen atom. A is true, R is true, R is the correct explanation for A. See the next question. CH3COOK undergoes electrolysis. Sodium or potassium salts of carboxylic acid undergoes coal-base electrolysis. Take 2 moles of CH3COOK, sodium salt of carboxylic acid, undergoes electrolysis. Electrolyte is required, that is taken as water molecule. Now it undergoes electrolysis. Then H2 gas is evolved. CO2 gas is evolved. A new CC bond is formed between two alkyl group carbons, CH3 bond CH3, 2 moles of CO2 plus H2 plus 2 moles of KOH. Alkane is formed as a product. Which alkane is formed? Ethane is formed. Correct option is first option. This question is also discussed in last video. Alkaline hydrolysis of ester. Alkaline hydrolysis of ester. The ease of alkaline hydrolysis of ester is directly proportional to electron withdrawing group, inversely proportional to electron donating group. NO2 is strong electron withdrawing group, so 3 Ks more. And OCH3 acts as strong electron donating group compared with remaining. So 4 last. First 3, 4 last. Correct option is first option. The next question, wrong statement of the following. Which is wrong statement? Third one is wrong statement. Aromatic carboxylic acids are more reactive towards Friedel-Crafts reaction. This is wrong. Why? Aromatic carboxylic acids do not undergo Friedel-Crafts reaction. Why? Because the carboxyl group is deactivating and the catalyst Lewis acid gets bonded to the carboxyl group. That's the reason aromatic carboxylic acids are not participate towards Friedel-Crafts reactions. The next question, ketone in the presence of dilute base. Ketone contains alpha carbon, alpha hydrogen atoms are also present. So it participates in aldol condensation reaction. Aldol condensation reaction take two same type of aldehydes or ketones. Undergoes aldol condensation, then remove water molecule from first compound. You can remove oxygen. From second compound you can remove two alpha hydrogens. New CC bond is also formed here. Double bond. This is the final compound. Remove water molecule in the presence of dilute base. Two alpha hydrogens from one compound, oxygen, carbonyl oxygen atom from another compound. So question is the number of pi electrons, pi bonds. How many number of pi bonds? 2 pi bonds are present. How many number of pi electrons? 2 pi bonds, 4 pi electrons. So second option is correct option. See the next question, metachlorobenzaldehyde. Yes, this is the metachlorobenzaldehyde. Reacts with KOH. That means chemical reaction takes place in the presence of base. Metachlorobenzaldehyde. First of all, you can check. This is aldehyde. Adjacent carbon is alpha carbon. Alpha hydrogen atoms are present? No. Alpha hydrogen atoms are absent. Alpha hydrogen atoms are absent. It participates in Cannizzaro reaction. Cannizzaro reaction case, self-oxidation and self-reduction takes place. Aldehydes undergoes self-reduction, then it gives alcohols. Aldehydes undergoes oxidation, then it gives salt of carboxylic acid. So the correct option is second option. This is chlorines. Chlorine atoms are unaffected. Why? Because this is haloarine. Haloarenes are not participate towards nucleophilic substitution reactions. See the next question. Which among the following aldehyde is most reactive towards nucleophilic addition reaction? The nucleophilic addition is directly proportional to electron withdrawing groups, and inversely proportional to electron donating group. Remember, here alkyl groups are acts as electron donating groups. You can consider among aldehydes and ketones. Aldehyde and ketone. Aldehyde and ketone. Aldehydes are more favorable towards nucleophilic addition reaction because here only one alkyl group is present, but in case of ketones, two alkyl groups are present. In case of aldehyde, you can compare with the formaldehyde. In case of formaldehyde, there is no electron donating groups. That's the reason formaldehydes are more reactive towards nucleophilic addition reactions.